Alrighty, so we are going to, you could probably hear my cat, go through our first lesson with factoring with algebra tiles. And what I want to cover in this lesson is what are we doing when we factor? So we don't want to just do this procedure. I don't want to teach you an algorithm. I want you to have a solid understanding of what you are being asked to find when you are being asked to factor. And then how can we model factoring with area and with the tiles? And you might be able to tell that this particular, oh gosh, I'm gonna have to stop my cat from chewing the computer cord. No, girl. That's going to be ongoing for the duration of this video because for some reason she loves to do that. But how can we model these with the area and the tiles? So I am going to be clicking over to the online algebra tiles so that I can work with those, and hopefully it'll go okay. So first off, I want to focus, we're going to be focusing on factoring trinomials. Now the prefix tri, I think you probably know, means 3. I don't even know if you can see that based off of where I cut off the screen thing. So yeah, you might not be able to see that. So and there's no way I'm going to know that till I play back the video. So we're going to be focusing on factoring trinomials. So if I am rewriting something that is already on the screen, I apologize for that. Trinomials, but I'd rather write it twice than not have it on the screen at all. And by that, we mean 3 terms. So prefix tri means 3, and the 3 terms are the ax squared, the bx, and the c. And what we are trying to find are the factors that multiplied to give us that trinomial. So I'm going to give you an example. For example, on the left-hand side, look at the left first, all right? So on the left-hand side, we have 2x plus 1, and that is one factor. And there's my multiplication right in the middle there, and that is multiplying x plus 2. And so those are 2 factors. And when we multiply them together, we can use the area model to do that, we would get 2x squared minus 3x plus 2. Okay, and that's the multiplying direction. And it's one of the reasons why when we've gone over some stuff recently that I have emphasized using the area model to do it. Now in factoring, you are given the 2x squared minus 3x minus 2, and you are asked to find the 2x plus 1 and the x minus 2. So when you see those directions to factor, you're looking for the 2 things that multiplied in order to give us that trinomial. Now, I want to recall the basics of our area model. With the area model, we have essentially 3 tiles. The first tile is that big blue square, or I think in one of the sets, no, it's the green is like a lighter blue or something in one of the sets of algebra tiles. Now the dimensions, no, baby, I know you're hungry. The dimensions are x by x. So the area is x squared, but the actual side lengths are x and x. And we want to remember that because, like, again, we're working with area. With the green rectangles, we have the height is x, but the width, I can do that a little bit better. Let's see. But the width is just a 1. And then with the yellow tiles, okay, they are 1 by 1. And of course, if you like multiply the dimensions together, you get the area. And that is the geometrical like undergirding of what the model does. So when we are modeling, say, if you were modeling the polynomial x squared plus 2x plus 3, you would take 1 of the blue squares, 2 of the rectangles, and 3 of the yellow squares, and that would give you the total area. So we're taking x squared plus 2x plus 3, and we're representing that as an area. Now, the rules for the tiles. We went over these when we did completing the square. Some of you were in class, at least the year that I'm recording this. So I might reuse the video, but there was like a testing day that day, and there were a bunch of people missing, especially from my B-Day class. So we were like down a lot of people. I think there was testing on A-Day as well. So some of you might not know these rules. First of all, only edges of the same length can align. So you cannot do something like this where you have a square and then you put the rectangle up against it like that. If you've got the square, the rectangle has to go up against it that way. You also can't put like the little square like there, you can't do that. You can line that up there. Okay, so only edges of the same length can align. The base and the height must always equal the area of each tile, and that includes if you're dealing with the negative tiles. So I'll bring that up also in a moment or two. So like, yeah, like every part of it, the base and the height should give you the area. And the red tiles signify a negative. When you're working with the tiles, make sure that you don't flip them over to the red side unless you are trying to model something negative. So those are some of the rules for the tiles. Now, here's the strategy that we're going to use. First, model the quadratic in standard form. So model it in standard form first. In other words, gather the tiles that are going to have the right area to represent the quadratic that you have. If the quadratic is factorable, now remember that not all quadratics are factorable. It's why we need the quadratic formula, because not all of them like will this work. So it's not like every combination of tiles will do this, but if it is factorable, you will be able to arrange the tiles in a rectangle. Okay, and there's a method for being able to do it. Now, while they can be arranged in different ways, so you could jumble them all up and find some beautiful geometric way of arranging them, it will be best to do the following. Place the big squares in the upper left. So your big blue squares, your like X squares, okay? Put those in the upper left corner, and they might all be in a line. They might form a square themselves, okay? Then put the rectangles along the edges of the big squares. And we did this when we were completing the square. I went through like why it is best to arrange them a certain way, even though there are other options. And then put the little squares in the lower right. So essentially, you're going to have something like this. You're going to have the big squares. You're going to have the rectangles like kind of positioned here. And then you're going to put the little squares down in the lower right. Now, this will help us when we generalize the strategy to not use the tiles. Obviously, we could have numbers that were so big that we just don't have enough tiles, or the tiles is really not going to be a great way to do it. So we do want to move away from the tiles. If your tiles are arranged in this hodgepodgey way, even if they make a rectangle, it's going to be harder to generalize. And so we want to kind of like be consistent with this pattern because of where we're going to go with it, not because, it's better or more correct. It's not more correct, but it is going to be more useful. Okay, so that brings us to these three practice problems. So we're going to do x squared plus 6x plus 8, 2x squared minus 7x plus 3, and x squared plus 3x minus 4. So if you want to pause the video and just jot those down, because I am going to have to click off of this in order to model them with the tiles. And it's not going to let me escape, so I'm going to have to go through that. We are going to discard that because I would like to keep that. And we'll click over here to our algebra tiles model here. So the first one we were going to do is x squared plus 6x plus 8. So the first thing is to gather the tiles to model the area in standard form. So I have x squared plus 6x x, so that's 1, 2, 3, 4, 5, 6, plus 8. And I actually am not sure I wonder if it will let me, oh, it does let me do it with my finger. I don't have to keep clicking on my mouse. Well, that's way faster. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there they are. Now, if this is factorable, then we will be able to make a rectangle out of it. And just for the record, I am not going to, at least at the beginning, give you anything that's not factorable. Now, that can happen where a teacher will say factor if possible, and that can leave you scrambling to try to figure out if it's factorable. Before you then you gotta kick over to something else. But I'll give you stuff that's factorable. So now remember what I said is we want that like big blue square. We're gonna keep that in the upper left, and what we're gonna do is arrange the green tiles like along the edges. So I'm gonna need to rotate some of these because I do need some on the other side. And essentially what I'm going to do is just like put these in some places. So I'm going to start with this. I'll evenly divide them, which is what we did when we were completing the square. And I'm just going to kind of arrange this, and there'll be a trial and error element to this. So what to do? Okay. And right about now, I begin to really, okay. I left my mouse at work. That was awesome. That like moved out. What is happening? Okay, I'm just gonna come grab one of these. I don't quite understand what was going on there. Righty, it does not want to, it does not want to place the tile in there. Well, that's weird. Okay, well, what we can clearly see here is that we are not able to make a rectangle out of that. So what we need to do is we just need to play around this. So I'm going to take one of these, not that one, but one of these green tiles, and I'm going to move it up here. Okay, and then I'm going to now I got to like figure out where to put these. So put that one there. And that is the one that like, it really does not want me to put a tile there. Super weird. Okay. And now I have my rectangle. And so that took a trial. Like, so the first thing I tried didn't work. Now take a look at the dimensions of this. So remember, this has a dimension of x, and this is 1. So it's x plus 1 plus 1 plus 1 plus 1. So this is x plus 4. And this would be x plus 2 going down that side there. So x plus 4, x plus 2. And you could write it in either order. So you could say x plus 2 times x plus 4, because remember, the order that you multiply doesn't matter. Now, what I meant by the areas should match up. So like if you have a 1 here and you have a 1 here, 1 times 1 should give you 1. And so a positive times a positive gives you a positive. Like all of that should make sense. X times x gives you x squared. X times 1 gives you x, and so forth. But down here in this corner, a 1 times a 1 should give you a 1. All right, so there's our first one. Now I can click back. I will click back over to the other slide to write it down. But if you're following along, hopefully you're following along. It's x plus 4 x times x plus 2, or x plus 2 times x plus 4, whichever order you want to write that in. All right, so let's go tidy that up. And the next one we're going to do is 2x squared minus 7x plus 3. So we're going to have 2x squared minus 7x. So now we got to pull in these negatives, so that'll be fun. 1, 2, 3, 2, 3, 4, 5, 6, 7, and then it's a plus 3. So this looks interesting. So remember like the rules here. So like edges have to match up together. And we're going to try to keep these blue rectangles in that upper left corner. So I don't really have much choice but to like put them side by side like so. You could arrange them like this, like that would also be okay. It's just not going to work super well for the size of the screen that I have. All right, now do not do this. Let me put that there. Okay. I've like never had this issue with this before. I could pause the video and grab a mouse. I do have a mouse in the other room. Okay, so we're gonna line these up and I'm just gonna start to line the edges. Now I do need to rotate one. And I think what I'm gonna do is start with just like basically a layer, like so. And then I'll have to rotate that. And now I've got this extra one and I can't put it down here because I would need at least 2 of them in order to meet the rules. So I'm going to put that up there. And what I notice here is that that does not work. So that does not give me a rectangle. And so now I've got to like move some stuff. Now I could take one of these and move it over here, but that actually ends up making the situation worse, not better. So I'm going to go ahead and not do that. What I think I'm going to do is take 2 of these and move them down here. And then now I can move these over. And I think you can see how that's going to line up. Perfectionist me does actually want it to line up though. And of course we're going to have like that bizarro issue. Where as soon as I click on it, it like just will not let me place it. So there we go. I can do it that way. It's the only way to let me do it. All right. Now, how does this work in terms of the area model? So across the top, I have x plus x, which is 2x. And then this is a minus 1 right here because the length of that is -1. So I'll have 2x minus 1. And then going down the side, I have x minus 1, 2, 3. So x minus 3. Now I want you to notice the color of the circles over here, or squares over here, that they are +1. And we want to make sure that that is still okay. Well, if I have a -1 here and a -1 here, -1 times -1 would actually give me a +1. And so we're holding true to our algebra there. So 2x minus 1 is one of my factors, and x minus 3 is the other factor. And all of that piece like with the dimensions hold true. Okay, so if you're writing it down, it's 2x minus 1 and then x minus 3. Okay, let's look at one more. The last one was x squared plus 3x. And then this one is minus 4. And this one is going to be different. We've got some stuff going on. So we can start by doing this. Okay, so I'm going to line up one of my x's here. And of course, I'll rotate that one while I've still selected it. So that's great. And I'm going to have a problem. Okay, I'm going to have actually a couple problems here. So you start, oh, seriously. I guess I'm going to put this one down here. Okay. And then put this one here. Okay, I need to put that somewhere. And now I've got 2. Ooh, come on. I don't know if it's my computer that's acting up. Like I've really never had this issue before. I'm going to do something, flip it and like why it's not letting me pick that. Okay, I'm gonna do this. I've really never had this issue before, and I'm toying with the idea of going to get a mouse. But okay, so we have two issues. One is we have leftover pieces, so this clearly did not make a rectangle, and you know that I just said I'm not going to give you anything that doesn't make a rectangle. But we have another issue, and that issue is this. This is a positive one, and this is also a positive one. And a positive one times a positive one cannot give us a negative one. That negative one has to come from having a positive and a negative. Okay. And so we have that issue too. Like this would actually need to be a yellow square because a positive times a positive give us a positive, and I don't have yellow squares. So you might be wondering, okay, well, how do we solve this? This seems like a lost cause. Well, if you remember from when we were doing the completing the square, we can bring in something called a zero pair. All right. So over here, I'm gonna you can see where my mouse is circling. I have x and I have a negative x. And x plus negative x is actually 0. So as long as I bring them in together, I am okay. Okay, so on some of these, you might not be able to make like your rectangle, and so you're going to have to bring in these 0 pairs, and I don't know how many you're going to bring in. Like you might have to bring in multiple 0 pairs, as long as you bring them in pairs. Now here's the other issue. You cannot line those up that way for a couple of reasons. It's not going to solve the problem of the signs. So when I bring this like -1 and tuck it in there, and now I still have the issue of a positive times a positive gave me a negative. The other issue is that now I have like a plus x and a minus x on the same side. So like this is going to end up being something like x plus 1 instead of x. Like it's not going to show an accurate view of what it is. So when you bring in those 0 pairs, here's what needs to happen. All of your positives are going to need to go on one side together, which I guess is good in the sense that it will alleviate some decision making. So all your positives are going to need to go on one side. And then your negatives, if you have to bring in more negatives, are all going to need to go on the other side. And then you can start to fill in your units to see if you can make your rectangle. Now, this one is going to work to make the rectangle with just the 1 0 pair. But if I had -1s left over, I would just bring in another 0 pair. Now, so the dimensions of this rectangle are x across the top minus 1. So x minus 1. And then this would be x plus 4. Okay, so x plus 1, 2, 3, 4. And now check this out. Now our signs are okay. A positive times a negative gives us a negative. Positive times a negative gives us a negative, and so forth. So you need to pay attention to those signs as well. That will probably cause some hiccups at first, but just like remember what you need to check for. Okay, so you need to just check the signs on that, and you might need to bring in some 0 pairs. All right, so let's go back to our PowerPoint. And we were right here. And the factoring. Okay, so the first one was x plus 4 times x plus 2. And you might write it this way. Okay, so you can say x plus 2 times x plus 4 because multiplication is commutative. Like 2 times 3 is the same as 3 times 2. And that is multiplication in between there. We don't usually write a times sign, but those were the length and the width. And then the area was represented by the x squared plus 6x plus 8. The second one, that final answer was 2x minus 1 times x minus 3. And of course, you could switch the order as well. And the last one, we got x minus 1 across the top times x plus 4. And you could write that the other way. So your answer is going to be the 2 factors, like so. All right, so we've got some stuff for you to practice with. Now, if you're in class, you can practice with the algebra tiles. I'll give you guys a set. If you have numbers that are like super, super big and you're like, I need more than one set, we can work that out. We can manage that. If you are finishing for homework, you can use the same website I was using, or you can sketch them out. So some of you were already doing that on the last test. You were like sketching out the algebra tiles rather than uh, manipulating them. Now, the drawback to that is if you get it wrong, like unlike completing the square where there's like a real definitive method for how you want to set the square up, the rectangles might take you a couple tries, and that's going to be easier for you to just rearrange something physically than to like erase what you drew on the page. They do vary in difficulty level. Okay, so we are in, oh, I don't need a highlighter. We are going to start out with like some that are very, very basic. And then we're going to move towards ones that have like some bigger numbers in them. When you get the negatives at the end, that is likely when you need to start importing those zero pairs. Okay. Notice this one. This one does not have any rectangles at all. So you're gonna have to start importing some zero pairs right from the get-go. And you might recognize that as something you might already know how to factor. And then these ones, 9 and 10, both have 4x squared, but they are going to look different in your tile arrangement. So a little bit of a heads up on that. You guys know how to find me. I will make sure I link the website for the online algebra tiles if you're going to be doing this exclusively from home. And if you need more tiles, on the online algebra tiles, you can always pull some from the other side and then flip them. So I'll, if you need to pause here, take a picture of that, go ahead. All right, and I'm gonna take you guys back here for 1 second. Let's say you run out of like positive ones. Okay, so you're running out of positive ones and you're like, oh man, I need more ones. Grab a negative one, and then up here, there's a little button that says flip, and you can flip it over, and that will give you a positive one for you. So, all right, good luck, and reach out to me if you need some help.